Thanks, Megan. Welcome, everybody. Um, Hello, and I guess good morning from here in New York. But wherever and whenever you are, glad that you're here to listen to us talk about our Suga Citrate, which isn't a brand new product, but we have made some improvements to it, and I think those are going to be real positive for you to help consider this as part of your formulations. As I always do, we're going to start out with a little hygiene minute. I'd been doing hand hygiene for quite a while, so I thought I'd switch it up a little bit here today, and we're going to cover a little bit of oral hygiene, which is also tremendously important. And so, just a few tips here for keeping your mouth clean and healthy, and a, make sure that your teeth stay in good shape. We only get the one set of adult teeth, so they've got to last us quite a while. Hopefully, a good long life. So keeping your mouth and teeth clean is tremendously important. All right, so getting into it, kind of something that I've been talking about for really a long time in terms of um, beauty and what's important to the consumers. The words have changed a lot. The marketing lingo has changed a lot. Um, you know, different claims, different things that we talked about, be it natural or clean or what have you. Um, but fundamentally, there's been a couple aspects that have been consistent over a great many years, and really since I've been in um, even when I was on the consumer packaged goods and working in brands in beauty, um, these were the things that we talked about there. And so, you know, at the utmost and at the forefront, of course, is the consumer safety piece. We want to make sure that anything that we're marketing, putting out for consumers is going to be low irritation. Really should, the effort, of course, should be to have the lowest irritation possible, but with highest performance, of course. But that's always, front of mind. I just saw some survey data recently, uh, asking consumers, what was the thing that they were most concerned about when selecting, beauty products, and product safety was one of them. And unfortunately, I know a lot of the concern around product safety has been, driven by fear mongering. But fundamentally, consumers want to use products that they know are going to be safe for them. Um, should have low toxicity, and this is the concern. Um, that maybe isn't as well founded as the irritation. You know, maybe an over concern around some impurities or other ingredients that might be in the formulation that may have known toxicities, but not demonstrated to be toxic to the skin. Of course, there are things that are toxic to the skin. We should absolutely be avoiding those as well. Um, and then people want a product that's going to be functional. It's going to clean the skin or do what they want it to do, um, effectively. The second pillar is the environmental safety. People want products, of course, that are safe for them, but they don't want to be harming the environment in the process. So um, people are looking for reduced reliance on petrochemicals. This is the green aspects, high bio-based. Um, they don't want things that are going to be environmentally destructive at any point, and that means all the way from obtaining the raw materials to produce the ingredient that goes into the personal care cosmetic product, all the way through to the end of life when it goes down the drain um, and out into the water treatment. So, and then we don't want things that are persistent in the environment. So things should break down and you know get used up so they don't start to accumulate and pollute the environment and accumulate over a long period of time. And then there's a third pillar, which I guess, I think I've thought about more recently. Um, and this was not necessarily something that I was thinking about, 20 years ago. Um, but to maybe, if we can manage, some sort of a net good for the world with regards to, fair trade and responsible sourcing and making sure that products are inclusive. So, um, there's a lot of chemistry challenges, things that people are looking for, but also looking to avoid. Certainly with our own products that we have in the market, some of the pushbacks that we get, are like our APG carboxylates, not 100% bio-based. Even our, you know, APG sulfonate, the suganate, for many years when we first introduced it, before we were able to switch the feedstocks and we had available, the upcycled intermediate, we weren't 100% bio-based, and that was a barrier, to that product in the market for a long time. Thankfully now we've been able to reach or cross that threshold on that product to improve that aspect. But our APG phosphates, those are 100% bio-based, but occasionally we'll get some pushback on the phosphate aspect. We're seeing a lot less of that now. I think people understand the organic versus inorganic and the amount of phosphates involved in these products a little bit better. But even our APG sulfonate, after we went to the 100% bio-based, we would get some inquiries sometimes about the inorganic sulfate residuals in that product as well. And so that kind of causes us to consider our sulfonates, good or bad, fundamentally. And I think there's perfectly positive aspects, and maybe if we consider negative, probably fairly narrow. But if we look at all the sulfonates in the marketplace, of course, our first thing that we might think about is the sodium C1416 olefin sulfonate, which has become tremendously popular because it allows a lot of brands to claim sulfate free or SLS or SLES free, depending on how they're couching that claim. We've seen a lot of different iterations, but ultimately, a lot of people are using this ingredient to help them move away from the traditional SLS or SLES. And so here's what structurally that olefin sulfonate looks like. So that comes from, or has traditionally come from, the petrochemical alpha olefins that are distillates, and produced by primarily folks like Shell and Exxon and others. Um, so there are some advances coming in the future around improving the bio-based aspect of these, and actually in the near future. So we're definitely keeping our eye on that. But that is at least currently, a potential drawback there. Sodium colloidal isethionate has been used for a long time in the syndet area. I think a lot of people are moving towards this type of chemistry. Also, in the clear, shampoos and body washes as well, because of the high foaming, positive performance that way. The traditional colloidal isethionate, of course, has fair amount of fatty acid residual that differs by different grades, but it's always a significant amount to start, and that can sometimes create some formulation instability, especially at low formulation pH. But unfortunately, that's where a lot of us are trying to formulate, because we're using, in a lot of cases, organic acids to preserve formulas, or we're targeting the skin-friendly pH of 5.5, or in a lot of cases, we're even formulating, things for specific benefits like AHA or BHA cleansers, or formulating intimate care products, which require even lower pH. And so a lot of times these can become um, difficult or challenging if they're at high levels in the formulation. Then we got torates, which are also sulfonates. Better hydrolytic stability, much lower free acid, um, but they unfortunately are typically supplied as pastes or liquids that are finicky in terms of when they can become pasty. Then we've got our own suganate chemistry, and again, high bio-based. We were able to achieve the 100% biorenewable carbon with this product, but nonetheless, there are some pushbacks on sulfur chemistry in general, especially if the at any point there could be a chlorinated intermediate with the sulfur. That's a specific restriction within the Cosmos guideline, and so our suganate has been traditionally ineligible for Cosmos certification. So that's why we introduced originally a few years ago Suga Citrate L1C, but now we have Suga Citrate L1C MB. So this is RSPO mass balance, but it's also we took a deep look into the products and for any things that could potentially be barriers to us in the market, and when we came out with the Suga Citrate, we did run into some again Cosmos issues around our supply chain for the alkyl polyglucoside as well as the citrate portion. Both were sourced domestically, and so they had potential for use of genetically modified corn as feedstocks, and so that's a no-no for the Cosmos compliance, and so we've kind of taken a step back and re-looked at some of our supply chain and updated that so that we're fully Cosmos compliant now. So this does use our own patented APG derivative technology. So we were patent pending a few years ago when we first introduced this, but we do now have a granted patent on this chemistry. This is used to replace or augment, alkyl sulfate or sulfonate surfactants. And we have a lot of data now supporting its effectiveness in doing that. And we'll go through that in just a moment here. This product continues to be 100% bio-based end-to-end, so the anionic portion of the surfactant itself, so not counting the sodium counterion or the sodium chloride byproduct are completely biorenewable. So all the C's and O's that are part of the anionic surfactant itself are from biorenewable sources. This is a low irritation product that we've demonstrated to be not an irritant at 10% solid, so that's pretty high use rate for anionic surfactant. Very low irritation potential. We've also tested and demonstrated the product to be non-sensitizing per some in vitro sensitization tests that we've conducted. So we've demonstrated that this product is safe for people in the environment. I'll get into some of the environmental data in a bit here. But the goal here is to enable, formulators to be able to have something that's going to be, moderate foaming, moderate to high foaming, very low irritation, good viscosity response, and really highly compatible in a wide variety of applications. And so, places where we anticipate you guys using this product to be, as a primary, secondary anionic surfactant in these, quote unquote, sulfate-free type systems. And we know, again, that the definition for this sulfate-free, varies quite a bit. And that includes, in a lot of cases, things that may contain, trace amounts of inorganic sulfates, as long as it's not the sulfate surfactant. But again, I leave that to you all on the brand level to decide how you want to qualify or make the claim. But certainly mild cleansing anywhere that we want that, where we're going to generate and sustain good foam and viscosity building. And this can be used to reduce irritation in formulated systems. And it does a very good job at that. For wipes applications, it can provide, mild cleansing and wetting there in Syndet bars. And this is something that we're continuing to see a lot of people work around, dry form or solid form surfactant systems. And we think this would be a good product to augment potentially to provide, mild cleansing and foaming in those application areas, as well as the irritation reduction that is likely to occur with traditional Syndet bar formulations. In terms of the irritation reduction and its efficacy in that, we have done quite a lot of testing, and a lot of that is, has been both the in vitro, mat tech, and we also did some irritation testing as well. But we've been doing a lot of this, Zyme testing in our own lab, and we've talked a lot about that in the past. We had the poster at the SEC annual meeting a few years back, but we continue to do those tests in-house to demonstrate the ability of our APG derivatives, especially to augment and modify and improve irritation potential of formulated products. And so for the mat tech specifically, this was the in vitro test. Again, we ran it at a fairly high solids level, and we did this under the protocol to try to gauge exactly how irritating it is. So this would be, at the lowest tier of irritation potential. And this is usually associated with ethoxylated surfactants. And of course, the Suga Citrate L1C is not ethoxylated, doesn't include that type of chemistry, which we traditionally use to lower irritation potential. Is not part of this chemistry. So, traditional surfactants like the SLS or sodium dodecyl sulfates, you can see even at 3% is substantially more irritating, and then you get into some of the even higher irritation benchmarks. Also looking at the epiocular and its ability to generate Dray's equivalent scores, and we compare it to a number of other benchmarks. And every in vitro test is a little bit different. So generally, the trends tend to line up. The difference here in the MatTech epiocular between the sodium laureth 2 sulfate and the olefin sulfonate was pretty dramatic. This is not something that we had seen in some of the other in vitro tests that we've done in the past. But we are starting to continue to see this sort of data in some of the Zyme testing that we're doing, where the olefin sulfonate and formulated products from the olefin sulfonate seem to generate higher scores um, relative to the 2 mole SLES. And I think that's partially predicted, but the I think the extent here is what was surprising to us, and we do see a smaller delta in design testing that we're doing. So getting into that design data specifically, so we looked at a variety of again what colloquially people would consider sulfate-free systems. Um, and formulated platform using the anionics here. These were combined with a cocamidopropylbutane and cocamid MEA. And we've shown similar data like this in the past. This is kind of a formulation platform that we've now developed to do a lot of benchmarking and testing with the design studies and design. I guess just to reiterate, there is a corn protein, which has an amino acid distribution that's similar to skin keratin, and so we're looking here primarily at protein denaturization as as a mechanism for skin irritation specifically, but also could be implicated for eye irritation, of course, as well. Uh, but there are other, of course, in vitro methods, and we're also looking at expanding some of our body of knowledge and how we do some of these tests to incorporate some others as well. But this has been providing, some what we think is reasonable directional information around irritation potential and the effects of different ingredients. And so in the brown lines, we'll see the formulations with the uh, primary surfactants indicated, SLS, SLES, SCS, AOS, and the methyl isethonates. And then in the green lines, we demonstrate the mitigating effect. And so the green line is above the brown line for its associated base surfactant. And we're maintaining the amount of anionic in these systems. So we're not adding in more sugar citrate into these formulations. We're actually removing a small amount of the base anionic, and we're incorporating and augmenting that small amount of sugar citrate to go along with it. And so here we see, again, fairly dramatic reductions in the irritation potential from things like SLS or even the SLES, the AOS, all of them, it's a very consistent effect. We did do the methyl isethionate test at a slightly different pH, and that was due to clarity of that. We weren't able to achieve a clear, stable formulation for that at the pH 6, so we did drop it to 5, and that's per their formulation suggestions as well to do that. So zeroing in on just a couple things and maybe some concepts that I wanted to highlight and bring home. Uh, the moving away from sulfates has been something that's been going on for a while, but we did have, a number of customers that were hanging on uh, and continuing to use SLES because it was, fairly well evidenced for its, um, you know, fairly acceptable, skin irritation potential. Again, it's not at the low end, but it's not at the high end either. Certainly here you can see the difference between SLS and SLES in the formulation. It is, fairly substantial, and there's a reason why we used, the ethoxylated sulfates, because they did provide a substantial improvement in the irritation profile. Um, But then we had, a lot of these dioxane laws coming in. Some are already in fact, some are uh, coming into effect, and that's caused a lot of folks to kind of reevaluate the use of ether sulfates to either reduce or eliminate those in formulation because they can be particularly prone to having higher amounts of dioxane than would be allowable, especially under the New York State um, legislation, which only allows now for 1 part per million 1,4-dioxane, and the all the grace and extensions have run out on that now. So you really do need to be under the 1 ppm um, for consumer products for both personal care and home care. That's uh, we need to get that low dioxane. So how does one do that if they prefer to use the sulfates for whatever reason? You know, if you go back to something like SLS, you're going to increase irritation. But here we've demonstrated that you can combine the SLS with our sugar citrate at a 2-to-1 ratio of that in the anionic portion. And so this is a very modest amount of the sugar citrate going into the formulation, allows formulators to maintain a low cost in use of the formulation. But then now we can see we're able to kind of re-equilibrate and get back to the 2 mole SLES um, range in terms of irritation potential, and we can further reduce that, with more of the sugar citrate. But then potentially there are then trade-offs or reformulation that may have to be considered. In no small part because, as we can see here, in doing the one-to-one substitution, uh, the use of the sugar citrate not only increases the overall viscosity building, which is a positive, it also decreases the amount of added salt to get to peak, which is also a positive in a lot of cases. But remember that these are the formulations without anything added to them. So this is without any fragrances or preservatives or other additives. And so there is a potential that you could push yourself over to the right side or descending side of the salt curve and run into some lower than expected viscosity or physical instability of the formulation. So, um, but on the flip side of that, you could see that without any salt added, this formulation does have a fairly high viscosity and would allow a formulator to produce a no salt added formulation. So this is something that we've been hearing some of our customers ask us about. Um, you know, I did a webinar several years ago around salt-free formulations that's still archived on our website, and feel free to revisit that. But the it is a trend, and it is something that we still get some questions around. Is targeting no salt added formulations. Here with the AOS, I also wanted to highlight this data because we do know that so many of you have moved to AOS as a sulfate-free replacement for the traditional SLS and SLES. And here, um, again, we can demonstrate substantial improvements in the predicted irritation from these types of formulations when we incorporate some of the sugar citrate. And then again, we did see similar effects in terms of the viscosity build in shifting the peak viscosity of these. And AOS in particular is an anionic that's fairly sluggish in its viscosity response, and it can, in a lot of cases, take quite a bit of salt to build up viscosity. And so formulators, our customers, you guys out there, usually compensate by adding a lot of secondary and tertiary surfactants. Um, but incorporating the sugar citrate again helps to rely less on those and keep the overall formulation costs low, while both reducing the amount of salt and the amount of irritation in the formulation. Getting into the environmental impact, as I mentioned before, this product is readily biodegradable. The data is very positive for that. On the aquatic toxicity in our algae studies, we also have relatively high numbers here, and higher is better, of course. Um, and these are very favorable and indicates minimum environmental impact with this ingredient. Um, it's highly water soluble, so this is going to stay in the water and available for the microbes to decompose, and so a very low chance for bioaccumulation of the product. Now, I showed you a lot of data with the sugar citrate as kind of a secondary anionic. We all have also formulated a number of products using the sugar citrate as a primary anionic surfactant. These are incredibly low irritation formulations that would be, highly suitable for, a number of applications like distressed skin, leave-on cleansers, baby cleansers, things like that. Um, and here we're demonstrating how we can, manipulate a number of different formulation parameters to achieve good viscosity builds with in some cases, again, no salt added. Um, in the formulation. And so this is a quite versatile component for formulating, very good products with. When it's used as a primary anionic in formulation, we of course see some lower foam than we do when we're using some of those other um, surfactants that we've talked about earlier in the presentation. But not all applications necessarily require uh, high volume foam. Um, I think especially when we're talking about some of the very mild cleansing um, applications, then it's really the goal to be low irritation. Um, I think the foam in those tends to be somewhat secondary. We see a lot of cream cleansers, for example, for facial care in the market already. So you could have a clear formulation that has similar cleansing and aesthetics otherwise, and I think that's an interesting, product platform and concept for a brand, and that's where we would fit in quite well, with the sugar citrate in something like that. There's a couple other formulation examples. As I mentioned, we've got several of these. This is a formulation that we're demonstrating at in cosmetics, which as I'm recording this now will be next week. And so if you want to check us out there, if you happen to be at the show, um, then I would encourage you to stop by and have a chat, or look at our presentation, or our box in the innovation zone. And this product has been shortlisted for the In Cosmetics Global Innovation Award for functional ingredients. And again, we really did kind of rebuild the molecule from the ground up now to get the Cosmos compliance. Here we have it in a formulation that's more demonstrating its use as a secondary anionic surfactant in a more traditionally formulated platform. And again, very good foam viscosity performance out of this formulation. So here, quickly in summary, for the Suga Citrate L1C MB, um, see the inky name there, so we believe is very friendly. It's about as short as we can manage for a new anionic surfactant, and I think the citrate is very relatable for a consumer. Um, on the global clearances, we're still working our way through a lot of different things. We've definitely added a lot since we first talked about this chemistry. Um, so this is something that has some additional volume allowances globally. But if you have questions about that, feel free to reach out and we can discuss your specific needs. Um, some of the highlight key features I think I've pretty well driven in, but I did also want to highlight that, like our many of our other APG derivatives, this product is supplied without an added preservative, and that is, I know, attractive to a lot of folks for not bringing in extra ingredients and not having to add anything to a label, especially in places like the EU where we need to label all the intentionally added components. Wide variety of application areas, and we do have a lot of certifications, um, lined up for this one, including again the Cosmos approved, which was something that was missing in the previous version of this chemistry. Um, so I'm just going to take another 5 or 10 minutes here to give you a couple new product news bits. So we got a couple things coming down the pipeline that I want everybody to be aware of. One of the things, and these both, I guess, are related to the same kind of fundamental issue that we've been having. Um, and that is around the use of coconut only versus being flexible in the use of coconut and palm kernel interchangeably for some of our products. Um, it's the costs of these individually, the oils, does vary quite a lot. It's been quite volatile over the last several years here, and the difference in costs for the palm kernel and coconut oils has been swinging quite a bit and has been quite the cost differential is pretty large right uh, now relative to where we had been in just not too long ago even. And so we're trying to be a little bit more flexible in some of our products and giving you guys the options um, to still, if you want to have a coconut source product, or if it, where it makes sense to have something that's more flexibly sourced. And so one example of that is our Colamid CMPA has traditionally been a coconut only source, but again, because of the high cost of coconut oil currently, um, we are introducing now a product that'll allow us to be a little bit more flexible on that raw material sourcing, and we'll have the availability to be RSPO mass balance for you. Now, this does include a change in our supply chain for this product, and want to assure you that we've done a lot to ensure that nothing's going to change in terms of the product compliance here, especially the performance. So we looked at the Colamid CFPA in how it would perform in a formulation. And so as a formula platform, we chose our Coladent DEF60, which is already a blend of AOS, betaine, and the Cocamid MIPA. And so it becomes a convenient platform for us to look at changes in any of those three components. And so here we were looking at the alkanolamid portion from different feedstocks, and we have always had a high performance product with our Cocamid MIPA, certainly higher performance than from the standard oils or fatty acids. And so we produced internally, just for comparison, the same chemistry from our traditional sourcing, um, which is the methyl ester. Then we also looked at coconut fatty acid, standard coconut oil, and then what we came up with was a special fatty acid composition for the Colamid CFPA to ensure that we would maintain high performance. And so we've handily managed that. So comparatively, you can see the effect here. And so just, our Colamid MIPA has never been, equivalent to a lot of the other things out there. We've always had a performance advantage to many of the products out there, and we are maintaining that. Um, and here, I just to not put too fine a point on it, we did compare to a commercial product that in the formulation, and again demonstrated uh, the difference in performance between something that maybe is an off the shelf, uh, something that you may have seen a lower cost for. Um, because it didn't use the type of feedstock that we were using to produce the CMPA. So going to the CFPA, it does a couple things. It does introduce the flexibility with the coconut and palm kernel, but then it also is going to be a relatively lower cost product than our existing Colamid CMPA. So hopefully we'll make that more affordable for you. Um, you do lose the coconut only aspect, but again, we will have the RSPO mass balance if you're interested. And then second, like I said, related, we're doing a similar thing with our sodium cocoa sulfates. We're going to be adding in RSPO mass balance version of this that will use the coconut and palm kernel oils interchangeably. This is again, kind of in a pre-commercial mode right now, but more than happy to provide samples so you can evaluate. Um, if you have been using our SCS needles in the past, and the coconut only aspect of those has not been a big, I guess, driver for you to get that. We do with this, the coconut only version of this is also, we sometimes are in cycles where our ability to supply is a little bit disrupted, and so we this is also should help with being able to get products kind of in smaller quantities, spot buy, when you need it as well. And we did, again, do the performance testing. Here, in this case, we were looking at our Coladent Cocoa, which is a blend of the sodium cocoa sulfates, cocoa glucoside, and cocamidopropyl hydroxysultane, and evaluated performance between the two. And we really didn't observe any substantial difference in performance between them. The numbers here are negligible in terms of the differences. And so we again feel that this, if you want to switch over, it's not going to disrupt in any way. the formulations that you may have already developed with the STS needles, but we're trying to, again, provide more options and maybe more cost-effective options for you on these products. And so that wraps it up. I guess that leaves us a few minutes if there's any questions that might have come in. I know Megan's been watching for those.
Yeah, we had one question come in. This question says, can sugar citrate by themselves be thickened with salt, or do we need SLS or SLES for salt thickening?
Right. No, you don't need necessarily SLS or SLES. You do need some secondary surfactant. You'll need some kind of amphoteric. The sugar citrate and all of our APG um, anionic derivatives have, they do have a much larger head group than traditional SLS or SLES. And so this is something that I'm working on a presentation. I've already given it to a couple folks, but stay tuned here I'm going to really do a deep dive into uh, salt thickened systems and how we select surfactants and how they work. But the Because of the larger head group, it is going to be less prone to be able to achieve the really high viscosities that you can from things like SLS or SLES or AOS, for that matter. But you can get a good salt response when you're using in combination with an amphoteric, and a lot of times, for efficiency's sake and to improve the foam profile, we do recommend the second anionic surfactant, and that could really be anything of your choice, uh, including the isothanates or the torates or amino acid surfactants. We've, you know, really everything that we've done in terms of formulating around suganates, you can almost draw the direct parallel to sugar citrate. We see a lot of similarities in formulation and performance between those products. The main thing was to be able to have a product that was Cosmos compliant and didn't have even the sulfonate in the name for our customers that have been asking us, what can you do? What's the next step in moving that natural provenance of the product forward. So hopefully we've accomplished or reached the end goal here in having something that's as high biobase as we can get without really anything that's objectionable in the manufacture of it.
Okay, we had a few more questions come in. If you have a few minutes.
Sure.
The next one is there an amphoteric or amphoacetate surfactant that works best with thickening sugar citrate without having to use amides or PEGs?
Um, our choleric CBSHP is a cocometapropyl hydroxysulfane that's supplied at relatively high active, 50% solids. Um, and it is very good at generating viscosity with our APG derivatives. So that's usually our first line product when we're developing formulations with our APG anionics, is to use the choleric CBSHP. And that product, we have a lot of, again, positive irritation, positive being a beneficial, irritation data, good high bio based, it ticks a lot of the boxes that I think our customers have been looking for in terms of surfactants as well. So that's a great place to start.
Okay. Next, in your formulation discussions, you used the term mild cleanser. Did you mean mild for the skin or lower stripping type cleansing?
Ah, yeah, good point. Yeah, because a lot of the one of the other benefits of the 2 mole SLES was that it was not as defatting as a lot of other anionic surfactants. Um, I would say that for the sugar citrate, and really, again, I can speak more broadly about our APG anionics when I say this. They are fairly strongly defatting, um, very good detergency, and sometimes that can be perceived as a negative. So even though they have low irritation potential, low propensity to cause stinging or redness, uh, uh, issues with skin or eyes, they can be sometimes perceived to be drying, and so it is helpful to include skin conditioners or emollients um, in the formulation to kind of balance the feel when you're using them. Or in some cases, that can be beneficial, and people can leverage that to their benefit in the formulation as well. So it's really how you're trying to design the aesthetics of the product. Um, but yes, it is helpful, especially for like a facial cleanser to use some refatting products along with the sugar citrate.
Okay. Next, how is the foam heights and lather profile of sugar citrate compared to SLS, SLES, and AOS?
Yeah, I would say it's kind of in a different category, and that's why I usually say moderate or moderate to high foam. Those products tend to be at the highest foam performance, and that's why they have been, the surfactants of choice for formulators developing, high foaming cleansers. Um, and so a lot of the foam performance of the sugar citrate depends on how it's used in the formulation, and also how the product is used. And so this is something that's been unique and a bit perplexing for us around our APG anionics is that in the same amount of surfactant in one type of delivery system, different viscosity or different application method can be perceived to be much higher foam than in others. And so it becomes very hard for us to make blanket statements around the foam performance. You can get, for example, a body wash, you put it on the poof, and you get really good foam characteristics. And then the same formulation, if you try to wash your hands, for example, with it, you may not see the same type of foam. And so it's been a bit of a perplexing challenge for us, and we do try to coach people through that, but a lot of it again depends on how the product is formulated and the method in which the product is used. So,
Okay. Um, what other surfactants would you recommend in conjunction with sugar citrate to improve the foam profile?
um, well, we really like using our disodium lauryl sulfosuccinate along with it. That's our Colimate LA40. And of course, we've recently introduced the Sugadet LSDG and LSLG, which are liquid handling versions of that same chemistry. We are currently in development for the methyl cocoyl taurate, and once we have that, I think that'll be a great option as well. So I guess stay tuned for developments there. Um, but really, any anionic works well in synergy with our APG anionics and the sugar citrate, especially. And so that's why I like to use two anionics together along with the amphoteric, and that really is a chassis that we have found to be quite robust and amenable to a lot of different types of formulations.
Okay, great. That was our last question. So
All right, fantastic.